Hi everyone, today my team and I will be presenting on the topic of power supply with a focus on switch mode power supply or SMPS. Before we dive in, let me introduce our team. I am Dania Najiha binti Asmazul Iskandar, and with me are Imran Iskandar and Nur Kiasatina. In this presentation, we will explore the fundamental of SMPS, and understanding SMPS is essential in many applications due to its efficiency and reliability. I will be presenting the critical preparation step and safety precaution that must be followed before testing a switch mode power supply or SMPS. Number 1. Verify correct input voltage. First, make sure the AC input voltage rating is correct before plugging it into the power supply. This prevents potential damage to the device. Number 2. Ensure equipment is functional. Inspect all measurement equipment to confirm it is in good working condition. Number 3. Plan test point. Plan the test point carefully, identifying high and low pin for accurate voltage measurement. Number 4. Inspect for short circuit. Re-inspect the bridge diode and MOSFET areas for short circuit or solder bridge to avoid power trips or damage during testing. For safety precaution before testing. Number 1. Never work alone. Always have another person present during testing. Their presence could be critical in case of an emergency. Number 2, one hand rule. Keep one hand in your pocket when near a power circuit connected to high voltage system. This reduces the risk of creating a path for current through your body. Number 3, wear appropriate footwear. Rubber bottom shoes provide insulation and reduce the risk of electrical shock. Number 4, avoid jewelry. Remove jewelry and loose articles that could conduct current or get caught in moving parts. Number 5, clear the testing area. Keep the testing area organized and free of objects that might accidentally come into contact with live parts. Number 6, understand equipment grounding. Be aware that some devices use the metal chassis as a ground return, which might still be electrically live. Familiarize yourself with your equipment design before testing. This is SMPS block diagram. The first stage in an SMPS is the AC input voltage. This stage sets the foundation for the rest of the system by ensuring that the input voltage is steady and ready for processing. Number 2, AC filter and primary rectifier. This stage will play a critical role in cleaning and converting the input AC voltage. The main components here are suppression inductor, suppression capacitor X2 and Y2, bridge rectifier, electrolyte capacitor. Moving on, we have the high frequency inverter stage. This stage uses components such as switching transformer, inductor, MOSFET, and transistor. The purpose of this stage is to convert the DC voltage from the previous stage into high frequency AC voltage, which is crucial for efficient power transfer and size reduction of the transformer. Now we come to the control circuit stage, which use pulse width modulation (PWM). The main components in this stage are IC families like UC284X or UC384X and TL494 or TL594. PWM control is used here to regulate and stabilize the voltage. Finally, we have the DC output stage. This stage uses an electrolyte capacitor and a voltage regulator to further filter and stabilize the power.
So next, I would like to explain how to measure certain parts of SMPS by only using a multimeter. So the first thing that we can observe and measure is an AC input voltage. By switching our multimeter into AC voltage mode, we just need to place the probe across the live and the neutral input terminal. So our multimeter will show the reading, which is expected it should be around 110 volt to 230 volt, which match the power supply voltage. So during the lab session, we got the measurement value, which is 229 volt. So next is an AC filter voltage. So by keeping the multimeter still in AC voltage mode, we just need to place the probe across the output terminal of the AC filter. And then we will get the expected reading, which is the voltage should be similar to the input AC, but with a reduced noise. So during the measurement, we got the AC filter voltage value, which is 226 volt. So moving on to the next one, which is the primary rectifier. We need to switch our multimeter into DC voltage mode and then place the probe across the positive and negative terminal of the rectifier, and then we will get the expected reading, which is a DC voltage should be slightly higher than the peak AC input voltage, which is around 310 volt. So during the measurement, we got the DC filter voltage value, which is 323 volt. Other than that, on SMPS circuit, we can also measure high frequency inverter voltage. So by keeping our multimeter in DC voltage mode, we need to place the probe across the input terminal of the transformer connected to the inverter circuit, and then we got the expected reading, a fluctuating DC value or a small stable voltage, which indicating the switching is occurring. So during the lab session, we got the measurement value for the high secondary rectifier, which is 13.9 volt. So lastly, what we can observe and measure on SMPS circuit is DC output voltage. So by keeping our multimeter still in DC voltage mode, we need to place the probe across the output terminals, and then we will get the expected reading, which is a stable DC voltage matching the SMPS specification like 5 volt, 12 volt and 24 volt. So during the lab session on our SMPS circuit, we got the DC output voltage, which is 12 volt.
Hello everyone, my name is Nur Kiasatina binti Saha and I will explain for the result we get from this shop sheet about switch mode power supply SMPS. First of all, we measure at AC input supply. At its AC input supply, we will get 229 volts for AC input supply. After that, we need to measure AC filter. AC filter we get 226 volt. This AC filter is to convert a AC input supply to voltage DC. They're on the way. After that, we measure at DC filter. At the DC filter, we get 323 volt. At the DC filter, the more higher volt than AC filter. Why? Because at DC filter we have an electrolyte capacitor that has the function for store energy, and after that the energy transform to the charge. So that's why at DC filter more voltage than AC filter. Measurement value for high secondary rectifier is we get 30.9 voltage. As we know, high frequency secondary rectifier rectifier, the function is to rectify high frequency output voltage using high frequency diode, or as we can see this MPS use diode for that, and then convert DC voltage to require voltage output using DC to DC converter or regular IC. So after that, for measurement value at DC output, we will get 12 volts. For supply the machine, always the 12 volt. So that's all for my result explanation.
Thank you for your time and attention. We truly appreciate your interest and hope you found out our presentation both informative and engaging.